This video gives a brief overview of tests of significance and how to conduct them. The test of significance, basically what you're trying to do is test a claim about a population parameter, and you gather sample data and you see if that claim about the parameter is reasonable based on what the data are telling you. Now the claim that we're testing we call the null hypothesis. It's some specific claim about the population parameter. We abbreviate the null hypothesis this way as H0. And against that claim we offer a competing, more general claim, which we call the alternative hypothesis, or H sub A, about that parameter. Here's an example of what a null hypothesis might look like. This is saying that the null hypothesis is that a population proportion P is equal to 0.4. The alternative might say something like this: P is greater than 0.4. So you see the null hypothesis is specific, has an equal sign in it. The alternative hypothesis is a little bit vague. It says that we think that P is actually greater than 0.4, but we don't know how much greater. We don't know exactly what P is. So the null hypothesis is specific, the alternative is somewhat more general. Then you get data from a random sample and calculate a test statistic based on the assumption that the null hypothesis is true. This is a very important part of it. We assume that the null hypothesis is true just for the sake of argument when we're doing these tests. And then if that leads us to a place that causes us to question the null hypothesis, then we can do that later. But we use this as a working assumption in the meantime. Then we take a sampling distribution from that statistic and we calculate a probability called a p-value that we would get a sample statistic as far or farther from the H0 value, in this case it would be 0.4, as a statistic we actually got from our data, again assuming that H0 is true. So that assumption that the null hypothesis is true is the working assumption that we carry through the whole process. Now, once we get this p-value, we can make a decision about the null hypothesis and the alternative hypothesis. If the p-value is very small, and it's less than some level of significance, such as 0.05, which is 1 in 20 or 5%, or 0.01, which is 1 in 100 or 1%, then we reject the null hypothesis in favor of the alternative. A small p-value means that our sample statistic is unlikely to happen if the null hypothesis is true. So the sample statistic provides evidence that the alternative hypothesis is true instead. So that's the key thing. If you calculate this probability, this p-value, and it turns out to be small, then that causes you to reject the null hypothesis. Even though we've been using it as a working assumption all the way through, when we get to this point we have to make a decision about it, and if the p-value is small we reject. If the p-value is large, then what our sample is telling you is that we don't have any evidence that our sample statistic is inconsistent with the null hypothesis. And so in that situation you would fail to reject the null hypothesis and fail to find evidence that the alternative is true. So we have to make a decision between these two hypotheses. The null hypothesis is our working assumption, and if we find that our sample results would be very, very rare if the null hypothesis is true, then we reject the null hypothesis and in favor of the other. We find evidence that the alternative is true. Now, when you're conducting a test of significance, these are the steps you should follow. First thing is to state your hypotheses, both your null and your alternative, in symbols and in words. And then identify the type of test you want to conduct. There are several types that we're going to look at in the next few weeks, and you have to identify the one you want to use. Now, each test that you use relies on a sampling distribution, and each sampling distribution has necessary conditions that have to be met in order for you to use it. So you're going to have to verify that those conditions are met. And then once you've done that, you calculate the appropriate test statistic. That depends on which test we're doing. And then from that you calculate a p-value and compare it to your chosen level of significance, or what we also call an alpha level, and then make your decision about the null hypothesis. If the p-value is smaller than your alpha level, you reject the null. If the p-value is bigger than your alpha level, then you don't. And then you state your conclusions in complete sentences in context. That's basically how it works. And as we go through looking at different kinds of tests that we're going to do and the different kinds of sampling distributions that we're going to use. Hopefully with practice this will get to be a lot clearer